Okay, so this is a pretty fun chapter. We don't get to do all the sections, but this is a fun section. So we're going to be working with what's called a system of linear equations. Now, in the past, we've had linear equations, something like y equals 3x plus 7. That's a linear equation. Or you could have 3x plus 2y equals 6. Those are linear equations in two variables, and we've seen them as functions as well. But we're not going to be using them with the function notation for this chapter. Okay, so a system of linear equations is when we have two linear equations. So let's just take those two. Y equals 3x plus 7 and 3x plus 2y equals 6. When we put them together, then that's a system of linear equations. And what we're looking for, the goal, is to find the ordered pairs that make both equations true. Okay, that's the goal. So like if you were to graph this, we know we can graph a linear equation. So, quickly you could graph that. It has an intercept at 7 and a slope of 3, and it does, that's a very rough sketch, but something like that, right? It makes a line. Well, you could also graph this, 3x plus 2y equals 0. So if you think about 2, 0, and 3y, it probably does something like that, only straight, but something like that. So you're looking for the points that make both equations true. So this line here, I'll put it in orange, this line here, those are all the points that make this equation true. And then this line here, those are all the points that make this equation true. So what makes both equations true? Where they intersect. Okay, so that's the idea behind solving a system of equations. And we have three different, well, we actually have more than three different ways to solve them, but in this section we're going to show you three ways to solve a system of equations. First of all, though, I want to talk about there are three different types of equations. An independent system, that's the system I was just talking about. It's where you have one line, that you could graph, and you have another line, and they intersect in a point, at a point, one point. That point then is the solution. That point is an ordered pair, x comma y, whatever the coordinates are for that point. That is the solution for the system of equations. You can also have what's called that's called an independent system. You can also have what's called an inconsistent system. Do all lines intersect? No, because some lines are parallel. So you could have a line like this, and then you could have another line, different line, that runs parallel. They're not going to ever cross, and so there is no solution here. There's no point that will satisfy both equations, okay? And that's called an inconsistent system. Then there's a third case. You could have a line, and then it turns out that you have another line, but it actually is the same line. So they're actually just two lines, or the same line in two different forms. That's called a dependent system. And there's an infinite number of solutions. And the solution is the line. The solutions are the points on the line. So sometimes they'll write it as, say this line was x plus y equals 5. And then you had another equation that turned out to actually be that same equation. They write it, most often I've seen it as it's a set of x comma y such that, and then you just write the line, x plus y equals 5. Now you might be saying, well, there were two lines. How do I know which one to write? We usually write the one that's more simplified. Okay? So we'll be looking at those three different situations as they come up as we learn to solve a system of linear equations. And by the way, this is a system in 2 variables. So x and y.